Good morning, ladies and gentlemen. First of all, let's thank to God. With His grace, we can gather on the opportunity this morning. Thank you for the opportunity He has given us to make this presentation. Before this presentation begins, allow me to introduce my team to you. Wahyu as a speaker 1, then Hasan Gufron as a speaker 2, and Bayu as a closing moderator, and me, Novita, as opening moderator today. I'd like to give a presentation about smart trash. The next explanation will be continued by my friend. Wahyu, time is yours.
Abstract. Currently, the COVID-19 pandemic in Indonesia is still quite high. Therefore, the Internet of Things (IoT) system is extended to help reduce the spread of the COVID-19 virus. The system uses a Node MCU ESP8266 microcontroller and several sensors that are used to support this research. The design of this IoT system focus on measuring the distance between the trash can and the person disposing of the trash to calculate the opening and closing distance for the trash and measuring the height of the trash in the trash as a reference for cleaning works to pick up trash at the right time. This smart trash can open the lid automatically according to a specific distance and will send an alarm to be cleaning work smartphone and dirty when the height of the trash is full or reach a predetermined limit. Next, introduction. First, make trash bin smarter by utilizing a custom board and photoelectric sensor to reduce cost of refuse collection. Second, generate GPS data for route planning to accomplish this. Next, problem statement. 1. Sanitation crews visiting empty trash bins generated unnecessary cost. Second, reduce this cost by taking sanitation crews with visiting only full bins. 3. Overflowing bins increase pollution and reduce an area natural beauty. 4. Use data analysis to predict when bins become full. And next, impact. Positive, reduce unnecessary cost by having sanitation crew only visit full bins, increase natural beauty of an area by reducing pollution due to bin overflow. Negative, slightly increased carbon footprint due to manufacture and assembly of the board. Next, design overview. Utilize a network-connected board with a photoelectric sensor to report when the board are mounted to become full. Report data to a server which is synchronized to a management desktop application. The desktop application generates GPS data for input into route planning software. Next, smart trash can requirement. Component and figure. Uh, Number one, microcontroller Node MCU ESP8266. Number two, PIR infrared obstacle sensor. Number three, CSR04 ultrasonic sensor. Number four, passive buzzer. And last, number five, number five, Tower Pro motor servo MG90. Next, integration plan. Customer purchase the device, install on bins they manage. SQL Server instance will either be purchased by customer or from us. Management software is installed and begins managing the field device. Design detail circuit board. Intended design is to generate a custom board with uh, Wi-Fi or cellular connectivity, a, a photoelectric sensor, run the store a serial number and an embedded program to read and report the sensor data to server, solar panels for power. Prototype utilized a Raspberry Pi Zero with the photoelectric sensor, USB Wi-Fi adapter. Then it uh, then it will be read by Hassan Gufran as a speaker 2. Time to yours, Hassan Gufran, to next the material.
System architecture. Devices are added upon received in management system. C crash backed by SQL Server. Field crew deploy the device by installing them on pins and registering their location against the SQL Server using a mobile app. Software embedded on the field device. Java issues update to SQL Server at regular intervals. Central Management System listens for this update. Issues notification to user. Output set of full pin location upon request. Testing. Management system is modular, so unexpected behavior is minimized. Assembly uses the application while manually updating server to ensure proper response. Verify that data sets return contain desired data. Cross-reference timestamp of updates with log on embedded software. Ensure sensor remains powered and respond to stimuli, placement of hand or other object in front of sensor. Benefit or advantage of smart trash. Following are the benefit or advantage of smart waste management. It saves time and money by using smart waste collection bins and system equipped with field level of sensor. A smart transport vehicle go only to the field container or bins. It reduces infrastructure, operating and maintenance costs by up to 30%. It decreases traffic flow and consequently noise due to less air pollution as a result of less waste collection vehicle on the road. This has become possible due to by communication between smart dustbin and service operator. It keeps our surrounding clean and green and free from bad odor of waste. Emphasize on healthy environment and keep cities more beautiful. It further reduces manpower requirement to handle the garbage collection process. Applying smart waste management process to the city's optimized management, resource and cost, which makes it a smart city. It helps administration to generate extra revenue by advertisement on smart device. Drawbacks or disadvantages of smart trash. Following are the drawbacks or disadvantages of smart waste management. System requires more number of waste bins for separate waste collection as per population in the city. This results into high initial cost due to expensive smart dustbin compared to the other method. Sensor nodes used in the dustbin have limited memory size. Wireless technology used in the system such as Zigbee and Wi-Fi have shorter range and lower data speed. In RFID-based system, RFID tags are affected by surrounding metal object.
Okay, now I want to explain to about the conclusion. The smart trust system can be used to help user or business entities in knowing the amount of capacity of the trust in user home in real time. So that the improvement run the user can always be clean, hygienic. The device used is connected between a microcontroller, Neo MCU, sensor, ultrasonic and infrared, the internet, the blinking platform, and a smartphone that creates a smart trash can. Smart smartphone are used here as a monitor for the height of trust at a distance. If it is detect that trust is almost full, it will give a signal to the smartphone application that the trust is full. For further research, several more sensor can be added so that the accuracy obtained is better, or high verification tools due to external disturbance such as noise affecting the ultrasonic sensor. In addition, it is also necessary to add a database to the application so that user or business entities can be observe the pattern of the amount of waste on Christian Day. And what I want from you now, with technology advance that are already very sophisticated, it is hope the we can also dispose of garbage in its place. That is all from us. Thank you listening. Thank you.